ano, are we live? Not sure. All right.
Di pa po lumalabas.
Okay. So thank you for telling me that one. Okay. So I think in my phone, okay naman siya. So let's talk about
Ito na po.
yeah, let's talk about enterobacteriaceae a little bit more. So nasaan ang mga sagot ninyo? Bakit walang sumagot? Kayo talaga ha? Escherichia, tara Escherichia. Okay, very good. Wala nang ibang sasagot. Yan lang ang naalala nyo na Enterobacteriaceae. Yun talaga. Okay, so kung wala na, let's continue. Alright. Alright. Leishmaniasis. Hermione. Anong Hermione? Parang ako yan na. Hernamani ang ano. Parang ako yan. Parang ako yan si Sir Hermione. Okay. Sino si Herman? Yeah, I'm also thinking about what he just wrote there. Actually. Okay. Google warriors have arrived. Okay. All right. So, yeah. So let's continue. Okay na yun. Okay, ano no, Mark. Wala namang problem.
Wala po.
Pati sa Google, no? Wala. Sa
Apo.
Google ano natin, sa Google Meet natin. All right. So let's continue with general characteristics, of course. So, eto na naman tayo. All members na naman. So, matutuwa na naman si Amanda niyan. All members of the Enterobacteriaceae family are motile except for which of the following species? Okay, so don't forget Shigella species, Klebsiella, Salmonella plurum, and Salmonella gallinarum. Okay, so two members of the Salmonella family are non-motile. So it means to say that they don't have any capacity to move. All right. Okay. So what is the oxygen preference of all members of Enterobacteriaceae? Are they what? Enterobacter. Thank you so much. So what are they? Are they facultative aerobes? What type of oxygen preference do they have? Are they facultative anaerobes? Are they obligate aerobes? Or most members, or all members? Sorry, all members. They are what? Alexis. They're what?
Facultative anaerobes.
Very good, very good. That's one of the most important things that you need to remember. All right, that's the more one of the things that you need to remember. Let's move on to the next characteristic. Okay, all members of the Enterobacteriaceae family can ferment what sugar? Anybody can answer that one? Is it glucose, sucrose, maltose? What else? Lactose, arabinose. It might sound funny that I'm just saying these things, but you remember these are organisms that have specific sugar fermentation characteristics. So, Nigel, can you give me the answer for the first bullet?
Glucose fermenters po.
Huh? Blah blah blah. Parang nag-ano si Nigel,
Glucose
nag-whisper. Nag-wig si ano, nag-wig si ano, nakita ko nag-wig si Valiant. Natuwa ako. Napatingin si Ronelyn, oh. Na-distract siya sa glucose po. Okay. Napatingin si Ronelyn, oh. Naglalaro ka ng bubble pop, Ronelyn, sa paligid. Nakita ko yun. Napatingin siya. Nag-wig si ano. I love it. Alright? So, members are actually, the members of the Enterobacteriaceae family can be classified based on the fermentation of what sugar. Actually, you can classify them based on their lactose fermentation capabilities. Are they a rapid lactose fermenter? They are a rapid lactose fermenter, or they are a slow fermenter. So you can say those things. Okay. Now let's talk about the catalase positivity of these species. Okay. All members of the Enterobacteriaceae family are catalase positive, except for except for somebody Valiant. Ayan, nag-wig talaga siya. Natuwa talaga ako. Anak, you're making me
Except for
proud.
Shigella dysentery.
Ayan na, pumapalag na siya, Alexis. Humanda ka. Kinukuha niya ang dapat sa kanya. Alright? Okay, kinukuha niya talaga ang dapat sa kanya. Alright, now, let's talk about a family that closely resembles, not necessarily closely resemble, but are oftentimes mistaken by my students as members of the family Enterobacteriaceae. And this is the Vibrionaceae family, or the Vibrionaceae family. Okay? So, one test that we can use to determine the difference between the two, or determine whether or not something is a Vibrionaceae or a member of the Vibrionaceae, is that it tests oxidase positive. Okay, because what I mentioned before, as I mentioned before, what is uh, what is uh, what is the oxygen preference of Enterobacteriaceae members? They are facultative anaerobes. Therefore, they can do whatever, right? Except oxidize, right? They can do whatever except oxidize. So they are capable of fermentation. They are capable of, they might be capable of fermentation. So it could be. It doesn't necessarily mean that they are oxidizers. So oxidase test would be one way for you guys to understand the base differences between these two. Now, all members of the Enterobacteriaceae family are able to reduce nitrates to nitrites. I think you might not have an idea about this, but maybe let's try. Anybody know? All members of the family Enterobacteriaceae. This is just something that is nice to know. Anybody? Pantowea and Erwinia. Okay? Sir, tinatanong ba yan? Actually, it is a PAMIT question. It's a PAMIT question. It's nice to know, but not necessarily must know. But I added it there just for you guys to understand that maybe not. Okay? Yes din, sabi ni Sir Marco, sige, gagawa tayo ng case presentation. Pagsama-samahin natin sila nila Pastorella multicida tsaka nila Labibacterium tsaka Spirillobacterium, no? Pagsama-samahin natin, tingnan natin kung makasagot yung mga students. Gusto nyo ba next week, magbigay ako ng bacteriology pa rin ba ako next week, Sir Marco? I'm not sure.
Ano?
Bacteriology pa rin ba ako next week?
I think you have 6 meetings for micro.
Okay, so we'll talk about I'll give you guys an example. Bibigyan ko kayo ng example na ano. Bibigyan ko kayo ng example yung mga galing sa mga test bank ng BOC, yung kailangan may mga ano pa, yung mga pinipresent pa sa mga ano na case presentation ng mga pathologists sa US tsaka sa UK. Titingnan natin kung may makakasagot. Ano lang siya, katuwaan lang. Kasi ganun yung example ng mga questions na ibibigay ko sa inyo para hindi kayo mabigla. Kasi 'di ba ayaw ni Alexis nang nabibigla siya ng significant other niya, 'di ba? Ayaw mo nun, no? Ayaw mo, Alexis, no? All right. So let's move on to the antigenic structures that are important in the family Enterobacteriaceae. So there's three. You must remember all of these things because it's going to be extremely important for you to remember it, especially when we go to the pathology or the pathologic determinants of the organisms. So let's start first with OHK. Don't forget OHK antigens. All right. And the location of the following antigens is as follows. Somatic antigen is the O, meaning it's the cell wall structure. All right. Or the cell wall antigen. The H antigen is the flagellar antigen. Okay. And the K antigen is the capsular antigen or the capsular antigen. Depending on how you pronounce it, I don't really care as long as you select it properly or as long as you select the proper answer. Okay? Clear? Clear? Wala akong maisip na mnemonic for Amanda. I'm terribly sorry, Amanda. Okay? Terribly, terribly sorry. I hope you can put it in a one or fourth sheet of paper and then just post it in your house. So every time anywhere in your house, maybe in front of the basin when you're washing your face, para paggising mo sa umaga nagugas ka ng mukha mo. Ganon. Okay? So yan. All right? Hang on a sec. Yes, sister. Okay. Prospecting? All right. Urgent? Yes. Okay, so give me like 40 minutes. All right, thank you so much. Okay. All right, all right. Sorry about that. I got a little bit distracted with a couple of nurses who submitted the sample. Anyway, we're going to be finished in a couple of minutes after I give you guys the introduction of Enterobacteriaceae. All right, now let's talk about the antigenic structures in the Enterobacteriaceae family that is considered heat stable and heat labile. All right, now when you say heat labile, when there's heating, it's going to be either destroyed or it becomes coagulated. Depends on. So it's the understanding here when we talk about biochemistry. If it's protein based, it's more or less heat labile. If it's lipid or carbohydrate rich, it's heat stable. So let's look at it. The K antigen is heat labile. So where is the K antigen ba? Capsule, right? So therefore, it is heat labile. Um, and mostly structures in proteinous structures like the capsule is made up of a lot of proteinous material, and that's the reason why it's heat labile. Heat stability is the O antigen. O antigen is basically the cell wall, the lipid bilayer. If you're not familiar, if you're still not familiar with it, okay. And let's go to another antigen, which is the VI antigen. It's a specific family. It's a specific family of microorganisms. It's a specific. There's a specific family of microorganisms that uh, sorry, distractions. All right, may nag-message sa Facebook. All right, so a specific family of microorganisms are involved with the VI antigen, but just to avoid confusion, it's also a cell wall antigen, but it's different because it's only found in one specific member of the Enterobacteriaceae family, which is Salmonella, or the Salmonella family, or the Salmonella species. Okay, now, let's talk about flagellar antigens for a while. Flagellar antigens are usually denatured by either alcohol or heat, depending on how you want to identify the organism. Um, but those are the things that results to its destruction. And immunoglobulins. Immunoglobulins are also important when it comes to antigens. Um, Somatic antigen is targeted by mostly IgM because they're larger, IgG because they're much more specific. Okay, and they usually are smaller. All right, and yeah, so that's basically it. What is the main thing that you need to remember? The reason why IgM binds so much to somatic antigens is because the which one do you think is much more of an opsonizer? IgM or IgG? What's an opsonin? Opsonin is peppering, right? You guys remember peppering? Like antibody, fragments of antibodies. Hindi nila, nako, nagagalit si Sir Marco sa inyo. Nagre-react si Sir Marco. So, how many fragments? O, ito na lang, napakadali. Napakadali. When, how many fragments of base immunoglobulin molecules are there in IgM? There's five, right? That's the reason why it's called the pentamer, right? So when you break up the fragments of Ig, when you break it up more into smaller molecules, it forms opsonins, right? Those small fragments bind to the cell wall, or the somatic antigen of microorganisms. Okay? Yun yung tinatawag ng process of opsonization. Parang it's Greek or Latin, I'm not sure, for peppering. If you're familiar, if you look at your cookbooks, the last stage is usually peppering something like your spaghetti. You pepper it with either you sprinkle a little bit of salt or sugar, a little sugar tuloy, salt and pepper. Nakita mo dun sa taas, di ba, ganun. Yung, parang on the surface, you can see it. It's basically the same thing. So opsonization is like that. So when an immunoglobulin breaks up, usually it will, especially IgM, usually it would attach to the somatic antigen. For flagellar antigen, it's usually IgG because they have hypervariable regions. They are much more they are much more highly proteinized. So be mindful of those things. Okay. Now, biochemical culture and biochemical testing of Enterobacteriaceae family. Most of them are cultured in SHEM. Ayan na. Di ba matutuwa na naman si Amanda. Amanda, are you there? SHEM. Okay.
Yes,
So
sir.
most members of the family Enterobacteriaceae are cultured in the following culture mediums, or the media, sorry, the following culture media. Salmonella Shigella agar or SSA, Hectowin enteric agar, Eosin methylene blue, and McConkey agar. Now, which of the four do you think is most commonly used in the clinical laboratory? Which among the four? And because of its simplistic and less toxicological for its less toxicological properties. Which of the following do you think? Ayan, si Amanda nagsasagot.
Um, okay.
Si-
May sumagot.
All right, so it's Mac
Hindi, sige.
Conky. Right, so it's McConkey agar that would be commonly used. Okay, it's our go-to culture media. All right. Now, what about TSI? TSI is what? What does TSI mean? Valiant, anak. What does TSI mean?
Triple sugar iron.
True sugar agar?
Triple.
Okay. I thought true sugar agar. Nagulat ako. Naloka ako sa'yo. Nagwig ka lang. Naloka ako sa'yo. Okay. So, what are the components of triple sugar agar? Why is it triple sugar agar? And I want specifics. I want numbers and percentages. Important. You'll know later why. Kalimutan na. O, sige. Color indicator na lang. Color indicator. Ay, Nigel. Sige, Nigel. Alright, Nigel.
10 parts lactose, 10 parts sucrose, tsaka
Hindi ko
1 part
marinig, Day.
ng
Ano ba
glucose.
yan, Day?
Ay,
Magsalita ka closer to your microphone.
Okay.
Nahirapan talaga ako sa
10
iyo.
parts po ng lactose. 10 parts ng sucrose and then 1 part ng glucose.
Okay. Nabihila ka aking inay. Alright, so very good. Thank you so much. Thank you so much, Nigel. Alright, now the color indicator is phenol red, obviously, because it's going to change to yellow, right? And there's an H2S indicator. What's an H2S indicator? The H2S indicator that we have is sodium thiosulfate. Okay, so this is your triple sugar ion agar. Okay, all right. So these are the percentages. Please don't forget the percentages. The reason why I want you to remember the percentages is because there's something important. Now, indicate the reaction to, if there is H2S producing isolate. I think everybody knows what H2S production is. I already told you guys what it is already in the earlier. Something to do with sulfide production, right? When there is sulfur production, it's going to turn black, right? Forming ferrous sulfide. So anything related to to iron or ferrous molecules will turn black. So what happens? Hydrogen sulfide will will be broken down by sodium thiosulfate, produce hydrogen sulfide and sulfate ions. These ions will react with hydrogen ferrous sulfate, and they would form ferric sulfide. So that's basically it. Nothing as simple as that. Now, what about Leah? Are you guys familiar with Leah? We have 5 more minutes. Leah. All right. Maria Cristina McKay.
lysine iron agar po.
Okay. Now, what's the color indicator? Syempre, hindi pwedeng nag-transcribe ka lang. Okay.
Brom cresol purple.
Brom what?
Brom cresol
All
purple.
right, very good. Now, what's the H2S indicator? Somebody raised his or her hand. I don't know. I didn't see. Who knows the H2S indicator? Eliza.
Ferric ammonium citrate.
Very good. Ferric ammonium citrate. So these are the. Actually, it's supposed to be brom cresol purple, and I'm going to turn it into purple. But the color of the the color of the slideshow is so red that I opted to change it to a different color. Okay? So apologies for that one. Kitang-kita ko nga yung mukha ni Mark dito, red na red eh. Sorry ha. Sorry. It's supposed to be purple, so you guys get to remember it. But you can just change it. I will send a copy of it for you for your review. Baka hindi kayo mahilig sa ano eh. Don't worry. And I don't send it before my exam, before my lecture, as you remember, kasi gusto ko gumagana ang utak natin whilst we're studying. Now, what metabolic actions are detected by LIA? So, metabolism wise, it's detecting the amination and decarboxylation. And at what portions of the culture media is it detecting it? At the slant, it's going to detect the amination, and decarboxylation is detected at the butt. Okay, all right. So where's the slant? Where's the butt? You have a butted slanted. You have a slightly slanted or culture media. So you need to inoculate it by stab and streak methodology. Avoid any problems. Okay. Now, tryptophanase enzyme is used for the detection of what? It's used for indole test. So don't forget tryptophanase. And the media that we use is SIM, okay, or a peptone broth. The reagent that we use is Kovacs reagent or Ehrlich reagent. And the red ring or a purple ring is what we would see. Red ring in most books, so I just opted to select red ring. Okay? Indole test. So tryptophanase. Okay, so if the organism produces tryptophanase, what test should be used? Indole. All right? Okay, clear? Now, content of the indicator for indole test, okay, it's the long one. I think most of you have already exhausted enough of your memory, so I'll be the one to transcribe it for you. Para-dimethyl aminobenzaldehyde, PADMA, okay? Para-amino dimethyl benzaldehyde. And I think this is the last one, MRVP. MRVP is methyl red, Voges Proskauer. That's another test that you will talk about a little bit later on. Tomorrow, maybe next week. This test is used to identify what organism. Okay, this test is used to identify if the organism is able to release enough acids to overcome a neutralizing buffer. This is methyl red. Usually, the acids involved, which is being produced by the microorganism, is the following: lactic acid, acetic acid, formic acid, and succinic acid. Look closely at the acids. This comes from fermentation processes, right? When going back to your biochemistry in your biochemistry in your second years, you would notice that these are products from fermentation processes, correct? So this is something that you need to take into consideration. All right. Lastly is Vogue's Pro Scour. All right. So that's the last thing. I think that's the last part of the slide. Yeah. So Vogue's Pro Scour detects citrate production, acetoin. Sorry, not citrate production, acetoin. Another name for the substance is acetylmethyl carbinol, and the reagent that we use there is apanaphthol, and the positive result is red. Okay, clear? Most members of the Enterobacteriaceae family has a positive result with MRVP. Um, Usually we have opposite results with their indole and the methyl red. So opposite results mostly, most of the time. Sometimes they were variable, especially for members of Proteus species. Okay, now we go to this is the last one. Citrate utilization test. We use Simmons citrate agar or SCE. The color indicator is bromthymol blue, not bromcresol purple, not anything. So bromthymol. Sometimes some of my students they would forget what's the brom needed. Okay. Now, indicate the results for the following in citrate media. So acidic Simmons citrate agar would have a yellow color change. Neutral will remain green, and blue for um, an alkaline environment. Okay. All right. Malonate. Oh yeah, forgot to mention about malonate. Malonate utilization is positive. In malonate utilization, the positive color is blue, negative is green or yellow, depending on the manufacturer. Yeah, urease also is another thing that you need to remember. Urease is carried out in the uricase media. Sorry, urea Christensen media or the Stewart's broth media or the sub or the kuwa. All right, para kay Amanda yan. Para hindi para hindi makalimutan ni Amanda yung kuwa at saka yung sub. All right, Christensen's urea agar and Stewart's urea broth. Actually, much better is the Christensen's agar because it solidifies. The other one is the broth media is prone to contamination because there's liquids inside. I would prefer personally if I were to choose between the two. Christensen's urea agar is the better one. And again, the color indicator is phenol red. A urea producing organism will change the culture media to a purple color. Okay, all right, or a red color. Um, if the organism has urease, the urea will be broken down to ammonia and CO2. And because CO2 causes a lot of changes the environment to an alkaline environment, it will turn positive. It will turn positively red. Okay, and there are three organisms that are positive with urea. This is Proteus, Providentia, and Morganella. These organisms are oftentimes grouped together because of their capabilities to utilize urea. Okay, rapid urease producers are classified positive um, as within 2 to 4 hours. Okay, we have another mnemonic here. C keys, slow urease producers. So C for Citrobacter, K for Klebsiella, E for Enterobacter, Y for Yersinia, and S for Serratia. Okay, they are classified as slow urease producers because they are going to test positive more than 4 hours after inoculation. Okay, Citrobacter, Klebsiella, Enterobacter, Yersinia, and Serratia. Okay, ONPG is another thing used to detect which of the following organisms that we're going to discuss. An organism with beta galactosidase. It's used to determine late lactose fermentation. And the meaning of ONPG is, of course, orthonitrophenyl beta galactosidase. It's positive. The positive color is yellow. The positive result is yellow, and negative is colorless. Um, we're going to stop here with decarboxylation because I've used up enough of our time. We're going to continue on with this one. Mark, I want you to remind me next time that we stopped at decarboxylation. Okay? Is
Yes
that
po.
cool? Hello? Mark? Andyan
Yes,
ka pa
yes
ba?
po.
Mark, are you still there?
Yes, sir.
Napasobra na
Sumasagot
tayo ng
siya,
time.
sir.
Alright? Alright?
Yes po.
CKC, okay, pwede din yon. Or you can
Hindi,
say
kasi 60.
Yeah,
Mas 60
60.
yung
Oh my
akin.
God, o, 'di ba? Tinuturuan na tayo nila ni Sir Marco nyo. Kasi ang alam ko lang, C keys lang eh. Wala lang, charing lang.
Kasi,
Alright?
kasi mas mapangit yung akin, mas corny, mas madali tandaan.
Oo, oo. 60. Bongga. Mas madaling mas corny. Baliw ka talaga, Sir Marco. Alright? So, hopefully you guys learned something in this particular discussion of ours. Um, hope to see you guys next time and have a great week and weekend for you guys. All right? I'll see you all next time and yeah, good luck on your exams. Bye.